Awesome. Let's get to that. Okay, can you guys see my talk and everything?
Yeah.
We'll get started here. Thank you for inviting me, and it sounds like y'all are having a great time. And I guess I don't know. I've been called Dr. Buzzkill, Professor Buzzkill, and everything else because I talk about all the bad things that can go wrong, Dr. Death. So I guess with that, I'll just get started because what more can you do? So to start off, I guess I want to talk about why probably most of you are here, which is how do you make a small fortune in farming? And here are some of the crops I work with. I work on a diversity of specialty crops because in Indiana, the big crops are corn and beans, and I joke that I do everything else. But so, here we have cannabis, but this also involves cut flowers, aronia berries, hops, ginseng for anyone who isn't familiar. And how you make a small fortune in farming is really quite simple. You start with a large fortune and you work your way down. And here you can see cannabis, here you can see ginseng, hops, and these are just some of the diseases that I work with. And my goal is to try and help growers manage these problems to their satisfaction. So I just want to be clear that a lot of what I'm talking to you about today, this is work that we started doing in 2015. So we were some of the first people in the country to actually be legally growing cannabis, and that I do all my own stunts, which is kind of weird, but unfortunately in the world we live in, for some reason, people think women don't drive tractors, which is kind of crazy. So I will be talking about cannabis production, not just in the field, which is what most of the work I do is involved in, but also in the greenhouse. I do a lot of work with greenhouse growers across the board, and there isn't too much difference. And I will distinguish between those situations and the diseases that impact one or the other. For the most part, there's pretty good overlap or pretty bad overlap, I guess, depending on how you look at that. As far as diseases are concerned, but there are a few diseases that are worse in the greenhouse or worse in the field. So when those occur, I will try and clarify that. I guess the first thing I need to start with is to remind everyone that quote by Abraham Lincoln when he said not to believe everything that you read on the internet, especially when it has to do with cannabis. There is when I started this, I agreed to do this because one of my colleagues pointed out that, oh, this doesn't have a lot of disease problems. This one should be a really easy one for you. Unfortunately for all of us, nothing could be further from the truth. So this is a brief list of all of the pathogens we pulled out the first year we did the trial. And it was actually, it goes on till there were over 90 different pathogens, and a lot of them were the same thing that we kept pulling out over and over. But most of the pathogens that we pulled up happened to be fungi. And I'm always sad following Suzanne. One, she gives a great talk, but two, everybody knows what insects do. Everybody knows, when a Japanese beetle eats something, and when it's eating something and when it's pooping, all of those things are pretty easily understood. Whereas most people literally have no understanding of fungi whatsoever, other than, that it shows up sometimes. We're not quite sure where it shows up, why it shows up, and mushrooms. And that's the extent of most people's understanding. So I'm going to give a lot of background when it comes to understanding fungi, because there's more to fungi than just mushrooms, and they are incredibly cool and incredibly beautiful in their own way. And so I really just think we should be giving them a lot more appreciation and love than we do, although not when they're obviously causing diseases. How many of you guys have actually done or worked with plant pathologists or gone to any talks from plant pathologists? I'm just kind of curious. I can sort of see hands raised, maybe a few people. So then you're very familiar with the disease triangle. And as a plant pathologist, one of the things I have to do in a talk, I mean, it's almost like the rules. I have to put my hands up here and give you this benediction of the disease triangle. And it seems kind of silly. And I remember when I was a new student, professors just getting all up in their stuff about how important this is. But as time goes on, really, it's such a beautifully elegant model to explain everything that we see. And whenever there's a disease problem, it's really important to understand how the disease triangle has a part in that problem. And really, when we think of disease, it's this perfect storm of having a susceptible host, which in our case here is cannabis. It doesn't matter if it's CBD cannabis, fiber, seed, or marijuana. It's all cannabis. And then it has to do with the pathogen being present. And the pathogen not only has to be present, but it has to be pathogenic. And then we need to have the right environmental conditions. For those of us living in the Midwest or living in the Northeast, unfortunately for us, more often than not, we do have the right environmental conditions. And just as we think, okay, we don't have this environmental condition, maybe it's hot and dry, and we've gone to cool and wet, we come up with a different set of pathogens that can exploit this new situation. So I'm going to start at the ground and slowly work my way out. And I'm going to start with the Damping Off movie. And I have certainly watched these movies several hundred times, I will be honest. I think they are phenomenal. I have no problem watching these movies. I think I wish they would have been around when I was a student, because they explain things so much better than me showing you like a life cycle diagram or something. And I really hope that there's a mic coming in so that you guys can hear this.
From the very beginning, the formation of healthy and vigorous roots, in this case wheat seedlings, is critical for the plant's vitality and for future yield. However, each soil is inhabited by numerous species of microorganisms that obtain nourishment from the roots of their hosts. Major parasites on cereal roots include some species of nematodes, oomycetes from the genus Pythium, as well as numerous pathogenic fungi. For example, Bipolaris sorokiniana, various species of Fusarium, and last but not least, Rhizoctonia solani, a frequent cause of seedling death and root rot.
So I apologize that, that's showing wheat there, but what I want to kind of do, and I'll pull up a couple of these different videos, is to get you to develop an understanding and appreciation of these disease problems so you can better understand and manage them. And so starting at the bottom here, and sorry I have to keep moving this stuff around, I want to just show you, this was actually a seed germ test that we had done to begin to identify where some of the problems that growers were having when growing cannabis. And here you can see this was actually drilled in, and you can also see what the price. Now this was an agronomic crops. We were generally paying, I believe it was $40–50 for 40 to 50 pounds of seed. So not horribly expensive compared to people who are growing cannabis for CBD production, where people are literally paying anywhere from 50 cents to $1 a seed. So there's a huge difference. Early on, people were actually literally paying hundreds, if not thousands of dollars for just a few seeds, which is, really one of the unfortunate things about this industry. What we found early on is that, and with this, we actually worked with the state chemist office, is that a lot of the seed that we were getting was not very good quality. And there's a number of reasons for this. The biggest one is the fact that, we haven't had the agronomy going on for hundreds of years, or at least decades even, like you have in other crops. A normal germ rate when you're looking at corn or soybean is a minimum of 95%. So we were all pretty shocked when we were planting these seeds, and some of what we were planting and paying hundreds of dollars for literally had less than a 50% germ rate. So this is nothing to do with any sort of disease. This is seed that was not harvested properly, that wasn't stored properly, and as a result, when we got it, it was no longer viable. So what we found when we planted this seed out in the field, and here's a couple of the different varieties that we planted, we had seed counts, and what we were expecting for each variety here, because we were planting different hybrids, different, this is a seed variety here, this is a fiber variety, so we were expecting higher stand densities, but what we found actually were incredibly lower. This difference here, even after we adjusted based on what our germination rate was, still continued to be much lower. So going in, I mean, essentially what we're looking at here is we were losing almost 50% of what we were putting in there. That's a huge cost that nobody can afford to maintain. We found out that the later we waited to plant these seeds, the worse it actually got, which wasn't too surprising. This was kind of expected in the literature because of the day length of the plant and everything else. But as you can see here, everything really bottomed out when we went after that June 12th date by thereabouts. And we've done this multiple years and repeated these results. So we were dealing with multiple issues going on with what was going on with our seed. Our seed were not harvested at the right time. They were not stored properly. And then on top of that all, we were having problems with damping off. Damping off is a weird term, something that goes back to, practically biblical times, which just describes the seeds either failing to emerge from the soil, which would be pre-emergent damping off. They never even, break out of the soil or emerge. And then what you see here is post-emergent damping off, where they get covered with fungi and different plant pathogens. You could also see here, and this was actually some started seed that the picture was sent in by a grower, the algae, which is a huge tip-off or clue that things are being overwatered, and is a big symptom of an overwatering problem, which then contributes to these root rots. And I'm talking about these different fungi, but no one can look at this, including me, and I've been doing this for 35 years. No one can look at this plant and sit here and say, oh, this is absolutely Pythium, or this is Fusarium, or any of these. You really need a microscope to go through to look at some of the distinct details. And some of these are things that, here, for example, Rhizoctonia, we have hyphae that appear at right angles and they have these septa, whereas these hyphae might also appear at right angles, but there's no septa. This produces a preponderance of spores, and here we have clamp connections. My point isn't that anyone expects you to know these things. It's that when you send it to someone who does, they should be able to show you this kind of evidence to go with your diagnosis. If you are dealing with the problem of damping off, and pre-emergent or post-emergent damping off, when the plants come out and then they flop on over, we really want to make sure that we get good samples in to help you with that diagnosis. And so you want to make sure that those plants are carefully removed from the soil to reduce the damage to the roots. Here we have a bunch of things going on where plants were too deeply planted. These didn't even have roots, and this one got a little twisted here. When we're examining these roots, we're looking at the structure. Are they water soaked? Were they planted like this here too deeply? Is there any structure visible? And some of this you could actually do yourself by just incubating it overnight and looking at a hand lens. When you are sending samples in, you can't give us too much information. More often than not, we lose time and even the correct diagnosis by not having enough information. And so make sure that you do fill out those intake forms. It doesn't matter if you're working with the Purdue Plant and Pest Diagnostic Lab, the UMass Diagnostic Lab, Michigan, whomever. These are all things that we need to help us with the diagnosis. Certain plant root rots and damping off have a lot to do, with the pH and the hardness of the water or the salts. Sometimes it has some clues, or the fertility, or even which type of media that you use. So when that plant is actually sent in to us, so here would be an example of something that we collected. We can see here we're dealing with a root rot. Here we're growing this root rot on a variety of different media. And this is looking at it underneath the microscope here. And this is a pretty telltale sign of Pythium. We needed to do a little bit more culturing. And then we even go so far in some instances to extract the DNA and send it out for sequencing. The fact that this can be done for anywhere from $20 to under $100 is pretty amazing. This is pretty much the same thing that is done in a crime scene investigation to a much greater cost. So that's what's happening behind the scenes. What are you going to be doing at the scene? Well, when we know what pathogen you're dealing with, we can start talking to you about what pot size you want to be working with, how to correct the media. For some pathogens, making sure you start with a clean slate. And this is really important, particularly for people who are trying to be sustainable. We'll want to reuse our pots a lot, which is a great option, but then you really absolutely have to make sure it's clean. A lot of times what people do will just throw it in bleach, or they'll just throw it in detergent. And in fact, the better option is to use some of these pre-made compounds, whether it's Clean Grow or Green Shield or Xerotal, which provides a combination. And this combination is important because I'm going to hopefully go back here. If you can see these really thick cells, I mean, these are like gumballs practically. I mean, they're only a couple microns across, but they're really thick. And if you put just bleach in there, it's actually impermeable to bleach. And if you put just alcohol in there, it's also impermeable. You need to have a detergent as well. So you want to make sure you have something soapy and then something to kill it, bleach and or Clorox or some sort of antibiotic, antibacterial sort of compound. When you're using your potting mix, you don't want to reuse it, and you don't want to use garden soil or add garden soil. I know that there's a lot of people who are always trying to say you want to have a healthier soil and add more things in, but one of the things that you can be adding in is Pythium, Phytophthora, Phalaenopsis, and things like that. Starting plants off and keeping them warm. The Pythium that I just showed you happened to be a cold season Pythium. And so if you start with a warm heating pad, you'll actually prevent the infection by some of these cooler Pythiums and maybe even Phytophtheras, although those don't seem to be too much of a problem, and certainly Phalaenopsis. Another important point is delaying fertilization. Cannabis is a really heavy feeder, but you really want to make sure that you're not adding too much salt in there, because the salt actually pulls the water out of the leaves. And as you pull the water out of the leaves, the Pythium that the leaves, or pull the water out of the roots, excuse me, the roots leak, and then the Pythium will actually find its way through that leakage and work its way in to infect the plant. In the field, you want to make sure that if you are incorporating cover crops, that you're incorporating it in early and making sure that the residues are actually broken down. One of the worst things you could do is putting in like a green cover crop, particularly something that might have had a lot of Pythium or Phytophthora or Rhizoctonia in there in the first place. We generally recommend to avoid the legumes, your beans and your vetches, because we find that increases the risk of root rot pathogens coming in. The next part is well-drained soils. If you are doing an outgrow or a field grow, where I am in Indiana, we have really, really heavy clay, which is a huge problem. And so you really want to make sure that in order to flatten that disease curve, you want to tile to promote drainage. And most of the problems we see are either on farms that don't have tile or just really, really heavy clay, or if you are doing a complete outgrow, it just happens to be too much rain, which has been a problem in a lot of locations in the eastern half of the US for the last few years. In a greenhouse situation, I should mention avoiding soilless mixtures that just have a primary component of rice hull. Rice hull is good, but it tends to really hold water. And I think we've gotten away from this as an industry. About five or 10 years ago, this was a huge addition to a lot of soilless media, and the rice hull really held in a lot of water, and we had some really bad outbreaks of Pythium. We want to make sure we have irrigation in the event we do have drought, but not so much irrigation that the plants get to be soggy as well, which I know sounds like common sense, but I think as we all know, common sense isn't so common anymore. So going on with Pythium and continuing with that, it doesn't just cause damping off, but it also causes a root rot, as you can see here, and in these pictures as well. It also can cause a root rot in hydroponic production. And these are actually, this is a Pythium aphanigermatum and Pythium ultimum right here. Again, these are all issues, poorly drained soil. Obviously in a hydroponic system, there's no competitive competition from other organisms to keep the Pythium down. And again, fertilization and high salts. So to understand how Pythium takes advantage of this, this is a promise you a much better movie than that last one. This is actually, I think, my favorite movie of all of them.
In many soils all over the world, the characteristic spherical resting spores of Pythium can be found. Well protected by their thick wall, these oospores often remain capable of germination for several years. When cereal seed, in this case wheat, has been sown, the seed absorbs water from the soil and swells. During this phase, various substances are released and diffuse into the soil. These exudates have a stimulating effect on the oospores. A germ tube is formed. Chemotactically attracted by the exudates released from the seed, the germ tube finds its way. Lateral branching of hyphae occurs, leading to the formation of a mycelium. As soon as the hyphae have reached the wheat embryo's surface and have penetrated it by means of enzymes, the parasite kills the host cells and starts obtaining nourishment from the decomposed organic matter. The embryo may die before it is able to germinate.
So when Pythium infects a seed for the damping off, this happens, but this also happens after that seed germinates. It's coming in a similar mechanism. It might be, though, more at the crown of the plant, and that by that I mean the base of the plant at the soil line. If it's particularly humid as well, it might even be above ground. So what do we do if we're managing this? Well, we've talked about trying to make sure we manage our water, whether we're talking about tiling agronomic soil or making sure our irrigation is well controlled, or berming even is another option. We also actually have, this is one of the few fungicides that is labeled. This is considered very low impact. It is not considered organic though, but it is available. This is phosphorus acid, and this is a mono or dipotassium salt of phosphorus acid. So this is something that is fairly natural. You might be able to find an OMRI certified version of this. It kind of goes back and forth, and it's sort of hard to keep track, but that is an option specifically for Pythium management. This same disease issue that we see occurs with Fusarium, okay? In that you have the seedling in the soil, damping off by Fusarium attacks the seed as it germinates, it attacks the seed after it's emerged. It can also even attack the bud later on in the harvest. This tends to be a big problem if you were coming in an area where there was a lot of corn production. This also happens in a greenhouse though as well, more as a root rot and a damping off though, as opposed to a bud rot. These pictures were by Zamir Punja. He's done a lot of work with this in British Columbia. Well, that's a little out there. So when we're trying to diagnose these things, once again, making sure we pull them up, making sure that we look at the root structure. We can't just look at these here. I mean, we have one that's Pythium and one that's or Fusarium, and you aren't going to be able to tell without a microscope. So don't assume that you know exactly what's going on. I'm not sure what's going on here. Another thing that you can do though, when you're working with this and trying to prevent this, and I'm sorry, something weird happened with my talk here, that something got jumbled up. And that has to do with planting depth. Here is one of the plants that was planted too deeply. And this also predisposes plants, particularly this happens with seeds planted too deeply. This happens with pre-started plants, if you're just taking them in the pot, that instead of staking a plant, which takes time and money, a lot of people will plant too deeply. This is something that people see encouraged for tomatoes. And I just want to make a gentle reminder here, these aren't tomatoes. And so what happens, and you can see this was actually planted 3 or 4 inches too deeply, that you can see here's this area right here. And then here are the roots. And what happens are the roots end up girdling the stem, circling around. And then they try to produce adventitious roots here. But as they're trying to produce these adventitious roots here, the roots down here aren't getting enough water, and you end up with a plant that has a lot of different problems. A lot of times these plants will succumb to fusarium, they will succumb to pythium, they will even succumb to botrytis, which will attack at the soil line. And we've had a number of people who have had lots of problems with that. The next type of root rot, which also can come in with these plants that are put in too deeply, include Rhizoctonia. This causes a dry brown rot on the root. Here you can see kind of the clumping right there, which might have had something to do with why the Rhizoctonia got there. It might have just been that the plant was pot bound. It could have also just been stuffed in the ground too deeply. It could have been compacted. Cannabis really doesn't do well with compaction, and this compaction could be due to any sort of mechanical compaction through tilling or through, tractor use or anything like that. But compaction can also, occur, just riding your ATV through a field. It could even occur through mishandling or poor planting. Regardless how this compaction happens or the crown or root rot, Rhizoctonia is one of the pathogens that can work its way in, and it creates more of a dry rot that you can see here. And this is affecting the crown. The roots aren't as bad as some of the roots I've shown you already. So here's Rhizoctonia and how it actually infects. And again, I do want to apologize that everything is like wheat or corn, but they're the ones who have the money, and the life cycle and disease cycles of these pathogens are the same.
Particularly in conservation tillage or no-till systems, which are becoming more prevalent in cereal growing areas around the world because of their environmental and economic benefits, the mycelium of Rhizoctonia solani can freely colonize the undisturbed soil, drawing nourishment from plant debris. But the fungus is also well prepared for adverse conditions. It forms compact structures consisting of tightly packed hyphae. These sclerotia can survive in soil for years until they finally germinate. The hyphae are attracted by chemical stimulants released from the roots of young host plants. Colonization of the root surface begins with long, sparsely branched hyphae called runner hyphae. These aggregate, forming a dense cushion. From this infection cushion, hyphae grow downward. With the aid of enzymes, the fungus destroys the intercellular cement. Gradually, the root tissue dissolves. The resulting macerated cells provide a rich habitat for the fungus. Depending on when and how severely the roots are damaged, seedlings may die, either by pre-emergence damping off or post-emergence damping off. Many plants survive the infection, though their root system is significantly reduced. The roots are shortened, having typical brown spear tips at their ends. As a consequence, the plants cannot take up enough water and nutrients, which leads to a reduction of yield. The stunted plants are often present in the field in patches, hence the name Rhizoctonia bare patch. Yield losses are proportional to the total area affected and can be as high as 50%.
So we actually saw something just like this actually with cannabis. I should have, I'm gonna, I'll, at the end, if somebody reminds me or asks, I have photos of a grow operation where it literally looks like this, where you have some plants that are looking really unthrifty, other plants that seem to be somewhat unaffected, and then the third set that is absolutely wiped out. The plants that died tended to be planted more deeply, but it wasn't 100% that way. There were some varieties that seemed to be more susceptible than others. We see more Rhizoctonia in the field in those years that tend to be drier. So when I first started working in this crop in 2015 and 2016, we had really unusually wet years and Pythium took over. 2017, we did a trial for Pythium, and of course that was a dry year, and Rhizoctonia killed everything. So when we're trying to manage in a field with field-grown cannabis, we want to rotate out of a susceptible host for at least 3 years. And this is a challenge, particularly in operations if you're growing multiple crops, let's say vegetable production, because Rhizoctonia is kind of a thug. Actually, all of these pathogens I've talked to you, with the exception of Fusarium, are pretty thuggish, and they will attack weeds and they will attack other crops. So rotating out does present an option as long as you're not rotating it out into another susceptible crop. Over irrigation early in the season, again, that root leakage is such a big thing to get that Rhizoctonia in them. And then finally trying to make sure that you aren't, moving these infected plants around or trying to, sometimes people, I've dealt with growers who, well, plants aren't doing well here, so I'm going to dig them up and move them over here. And really all they've ended up doing is spreading disease all over their planting site. So hopefully nobody's growing in a situation like this. But some of the things also to keep in mind, particularly if we're talking about the greenhouse, is the correct potting media, not reusing media, avoiding the over-fertilization. Fungus gnats and shore flies are actually big with Rhizoctonia and also Fusarium, Pythium to a lesser degree. And fungus gnats and shore flies are actually able to spread these pathogens. And I've hopefully convinced you that those are some of the issues, but there's other ways you can manage this that don't rely on chemicals. And one of the biggest ways is making sure that your substrate and your cell size match the size of plant that you're growing. And this is kind of a hard thing for people to wrap their heads around. But to make it real simple, when you're using a small cell size, you want to make sure you're using a small media. And when you're using a larger cell size, you want to use a larger cell media. And what you're trying to do is to make sure that the volume of the water being held is proportional to the space that you're holding that water in. And another way of let me go forward here, of looking at this is, and I'll just go back to that slide in a second, is a lot of times people want to skip steps. Nobody likes, growing a lot of plants, or most people don't like growing a lot of plants in a 288 cell flat and then having to up pot. It costs time and it costs money. But if you don't have the fungicides to do it the wrong way, or because of the constraints of a sustainable production system or an organic production system, that you have to do it the right way, you want to make sure that you're matching your plant size and your cell size. So for seed starting, these smaller trays is really, really important, because what it does is it gives you the right ratio of solid matter to water to air. And so those plants actually will start off well. And then as the plant gets bigger, you can increase the pot size. Going from here to here is almost always a recipe for root rot and damping off, and slowly working your way up is actually really important. And of course, it's not letting me go back. Hold on one second, so I can get back to this here. So some of the things to also keep in mind is not only making sure that your pot size is right or your tray size is right, but what you're actually putting in there. A lot of growers will really focus on trying to get peat, which is a great product. There's some sustainability issues, of course, with that. You want to make sure also that it's a good quality peat. For the most part, in organic, we avoid perlite and vermiculite. We will use a lot of bark, which will give you the larger, coarser sizes, which is really important. As long as the bark isn't overly composted or old, new bark is more coarse and doesn't absorb the water. Old or poorly composted bark really isn't going to provide you anything. Coconut and core are great as long, again, as it's good quality. We've had issues in the industry with some coconut or core coming in that was salty. which, as you can imagine, isn't good, period, but then adds to the problems with Pythium, and that also holds true with rice hulls. Right now, with all of the supply chain issues going on, I can't encourage you enough to get things earlier. Like if you haven't ordered this stuff already, order it yesterday, because there's just so many issues I'm hearing throughout the industry to get everything that we need. Another thing to keep in mind is that the taller pots, because you can get these azalea pots, which are small squat pots versus the tall pots, actually drain better. And as the cannabis plants get larger, these taller pots actually do really well. I know at one point there was a problem with that, and some people actually were going to red solo cups, which was a little shocking at first, but size-wise, that kind of ratio isn't the worst thing that you could actually use. Okay, so that's a little bit on the root rots and the cultural things. I'm not going to belabor too much with the pesticides since this is an organic group. But just to remind you that you want to make sure that what you're using has actually been labeled for cannabis. And that also includes for organic products as well. I realize that this is kind of a problem because pesticide products registration has been pesticide registration is a nightmare anyway, but for cannabis, it's been even more so. We do have a lot of products that do have organic registrations, different versions of Bacillus amyloidofaciens. And these are things that we want to keep in mind to use. And I'll talk a little bit more about those as we get to that. As far as their efficacy, this is some of the work that we actually did to show their efficacy or their lack of efficacy, or just give it a head by head. And this is a trial that we did, I guess now that's 2 years ago, almost 2 years ago. This is in one of our fields that had actually really high disease pressure for both Pythium and Rhizoctonia. And we have a number of conventional fungicides over here to the left. And then we have our Root Shield, which was an organic certified product right here. And as you can see, it didn't in this instance perform very well, but we had really high disease pressure and really nothing performed very well if you were looking at the seed strain X59. X59 is an interesting cannabis hemp product. It's also referred to as hemp nut. It's a really large seed. I like to think of it as a plump, juicy seed. And as much as I like it, the fungal pathogens like it just as much, if not more, which could explain why we had poor control of all of our products. When we were growing for fiber, though, you could see here that we actually didn't get much of a result, though, either. Now, here is another study where you can see that we did another evaluation, and once again, we had really high disease pressure. And what we saw was that this is our stand density, a higher number is better. The Root Shield performed maybe a little better than the control. It might have actually made things a little bit worse, as you can see here, statistically speaking. And so I guess my take home to you is there's a lot of products out there, and there are a lot of people who want to separate you from your money, and to make sure that there is actually some data associated with the efficacy of the product. I wish I could have better news. I do have other trials that we did, but I have to tell you, I've done this now for 4 or 5 years, and most of my results, unfortunately, look like this, in that our disease pressures are not horribly high, but they're high enough that we can discriminate differences. And most of the time, the organic product that we use doesn't provide a level of control that would justify its use. Here's a final one that we did. This was a large trial, a different spot. And this is where we put all of the biologicals head to head. And here you can see that the control, we had X59, just everything ate it for the most part. But with Erlina and Fertura, we had slightly better, or excuse me, just Erlina, we had better stand establishment, but we didn't get any sort of significant difference or improvement through the addition of any of these organic or biorational products. So that was pretty disappointing. This product is a Bacillus amyliquofaciens. Root shield is a trichoderma. This is a consortium of different products, and this is a biorational. And just, I mean, the work that goes involved in this, this was the second round of the trial where we did this, where we actually had pumps to make sure that everything evenly was distributed in the field. Most people don't have access to this kind of equipment. Before we had this, poor Sammy had to go out there and backpack on, we backpacked on over 250 gallons worth of treatments. So when I say, trust me, that nobody wanted this to work more than us, I mean, we were really tired and exhausted, and it just simply hasn't panned out the way any of us would like for it to work. So one thing I do want to remind you is, with all of these products, make sure that they're registered so you don't end up having your crop confiscated. And the first thing to start is the product registered in your state? If it is not registered in your state, it's not permitted for use. And every state is different, which is really unfortunate. An unfortunate reality of cannabis production and cannabis work. If it is registered in the state, you should have an EPA registration number. If there isn't anything registered, there is a flow chart for 25B products. These are products that are generally regarded as safe, and I call these the Thai chili cook, or the Thai cooking of products. This would be like your chili oil, your garlic oil, and things like that. As far as how effective they are for use, there's very little data to support their use, unfortunately. Sometimes it's about making yourself or the client feel better, so I will leave it at that. You need to make sure that the product that you're using is labeled for use in the greenhouse or indoors. Not all products are labeled. Very few products are labeled for cannabis, even fewer are labeled for cannabis use indoors. So you want to make sure, if it doesn't say so on the label, you can't use it. And that's an important thing to keep in mind. If you aren't sure about what is or isn't labeled, the National Pesticide Information Retrieval System is called NPERS. So if you just put NPERS into a Google search, you can get that information and find out that way. All right, so I've been focusing mostly on, for the first half of the talk, the roots. I want to talk about the foliage, and this is probably the area that most people see, which is, it's the part, that's in your face. Ironically, these are actually the least damaging problems on cannabis. Your cannabis isn't going to get to this point if the roots are bad, but unfortunately, since that other part is underground and essentially not visible, people don't worry about it. And so they tend to focus on this above ground portion even more. And the biggest actors in the above ground portion include botrytis, powdery mildew, and we've had some really big problems for field grown with downy mildew recently. And then of course the leaf spots, some of which you can see here. And even though I'll be talking about all of these different leaf spots, it's important to keep in mind that there's no law in the universe that says you can't have all of them on your plant. And unfortunately, for those of us who live in the Northeast or the Midwest, this is very often the case. So I'm going to start with botrytis, and botrytis is a problem not just in field production, but also in greenhouse production. Botrytis is a ubiquitous pathogen. It affects hundreds of crops, a huge problem in greenhouse ornamental production. It's also a huge problem in fruit crop production with strawberries and with grapes. Here in cannabis production, it's a huge problem with bud rots. And in some instances, here this was actually a cutting operation where they didn't even get to the bud rot or to the bud phase to rot. They were actually having an all-out blight due to the overcast conditions and the humidity in their greenhouse. And this is when you commonly see botrytis taking off. So in diagnosing botrytis, looking at that, it's just a nasty looking bud. You have these brown water-soaked spots. You might even find mold. You might even get it to go poof because it produces so many spores. This infection could actually happen, stop, and then take off as the bud matures. And as I showed earlier, it could also kill seedlings and cuttings. Managing this is actually something that all growers can and should do. And it's really important to keep in mind that plants need to be really well spaced and pruned so that it's a very open canopy. We tend to see this problem occur now if this is greenhouse production. In the greenhouse, particularly in those days that at least here in the Midwest in winter, it's oftentimes gray and overcast. I know from having lived in upstate New York, it's very similar to that up in the Northeast. I lived in Syracuse where it seemed like it was always gray and overcast. And this is when botrytis really thrives. So you could have a situation where everything is going great and your plants are just starting to look good. And then you have a week or two of gray overcast weather. And that's when you start to see botrytis blow up. The easiest things you can do is reduce the overhead misting at this time or overhead watering. Keep an eye on your humidity. And I know when it gets really cold, whether it's the Midwest or the Northeast, the last thing you want to do is let cold air get in there. But venting your greenhouse is actually the most cost-effective and cheapest way of doing it. And by venting your greenhouse, what I mean is opening up your greenhouse, pushing out all of that really humid air and cooling it down. Cool air can't hold the humidity, and it's that humidity that this botrytis really needs to get a foothold in for infection. We're working with a group to try and monitor and develop a forecasting system. And in order to get infection, we actually like bag plants. And if we don't bag plants in our greenhouse, we can't get any disease. So really monitoring that humidity and keep that relative humidity below 85%. Irrigate in the morning so plants have all day to dry. Fertilizing is so important. One of the things we do to get disease is we fertilize the plants with ammoniacal fertilizer. This would be, any sort of hot compost, anything that would be really high in nitrogen. These would be things you would want to avoid. This is where organic production is so superior to conventional production because you don't have these you shouldn't be using these hot composts or real high rates of fertilizer. And so by managing your fertility better, you can much better reduce the likelihood of botrytis. Out in the field, again, one of the big issues is trying to keep, flatten the curve and keep it down. If you have, heads that start to develop botrytis-like symptoms, you want to remove them. You want to make sure that plants are really well pruned. These plants that you can see in the background, they're too close together. It's too dense. And in the air in between here, there's not good airflow. In a greenhouse, you could use fans to drive that airflow. You can't do that in a field, particularly on a hot summer day. If it ends up being a cloudy, warm, wet summer day, that's when you're really going to see these bud rots take off. So from botrytis, we're going to switch over to powdery mildew. And I have to say we were pretty lucky where we were in the Midwest up until this last year. Everybody kept complaining about powdery mildew and we didn't have it. And a lot of people sent us photos and actually for those not familiar with the male plants, they produce a lot of pollen, and some of the people who were really worried early on thought they were having powdery mildew issues when it was in fact the pollen from the male plants. And this would of course be an agronomic production. You need pollen for seed set and everything. Powdery mildew though, unfortunately, got to us eventually. I know this is a huge, more of a problem in the drier conditions, which we haven't had up until recent years. The symptoms, or more correctly, the signs of the fungus are, as the name suggests, you get this powdery white growth. This is something that'll happen in the greenhouse or the field. Powdery mildew in general happens on the upper leaf surface, but don't believe that it's only the upper leaf surface. I know sometimes people say that that's what's going on there. And this can actually infect all stages of growth. It's rare that it happens with young plants. It usually starts to come in actually when the plant is starting to set bud. That said, these are generalities and plants don't read and they don't follow directions. So what's going on with this powdery mildew? Here's a video, and I like this one just because it shows how the infection occurs, and then we're going to talk about how we can try and keep this from happening.
If this wind-borne spore makes contact with a new host, it rapidly germinates, especially in hot and humid weather. The short germ tube attaches itself with its aprosorium to the surface of the leaf. From this adhesive organ, an infection hypha penetrates the wall of the host cell. This hypha releases enzymes, which facilitate the passage of the hypha through the cuticle and the outer cell wall. With a mechanical pressure of more than 20 kilopascals, the infection hypha indents the inner wall layer of the host cell. From this indentation, a membrane develops which covers the hostorium like a sheath. Via this nutritional organ, the fungus obtains nourishment directly from the host plant. The infected cell remains vital.
I think this is the second stage, I'm hoping. Yes.
With secondary hyphae, the fungus now infects the neighboring host cells. Being an ectoparasite, powdery mildew forms its mycelium on the outside of the plant. Its conidia develop from an onion-shaped parent cell. This grows in length and forms a transverse wall, thus isolating the tip of the hypha. By multiple repetition of this process, a chain of spores is created, asexual conidia, which gradually mature. Borne by the wind, the conidia can cover long distances. The result is a slowly increasing horizontal spread of the pathogen throughout the entire wheat planting.
So I hope you guys enjoy these things. I mean, I've watched these obviously a number of times. Then again, I've seen Rocky Horror Picture Show like 40 sometimes at least. So maybe it's just me, but I really like these because they show you what's going on and in a way that you can't actually see for yourself. And by understanding this, then it's easier to understand one, how something like this can develop from just a single spore, but also what you can do to keep this from happening. So the first thing I'm going to say, and I'm going to immediately apologize right after I say this, is use resistant cultivars. Unfortunately, we do not have reliable information about what is and isn't powdery mildew resistant. I can tell you our experience, which we have done and repeated and we will be publishing on, that the cherry line, at least where we are, seems to be uniquely susceptible to a number of different disease problems. And there's multiple different cherry lined cannabis species. But we have found it to be uniquely susceptible. So that would be a recommendation, and trying to go with some of these more resistant varieties so you don't have to deal with this mess here. We find planting them in non-shaded areas is really, really important, or more correctly, when I'm trying to get powdery mildew for a trial, we plant in shaded areas. Making sure that airflow is really good. Where we see this as a problem is as plants grow together, that airflow can no longer happen, and that allows that humidity permits the development of this pathogen. Now, powdery mildews are weird. It's not like a botrytis where it needs free water. It doesn't need any free water. It just needs humidity to grow and really take off like that. So by pruning out those branches and opening up the canopy, kind of, essentially limbing up like you would a shrub, you're actually improving the airflow and preventing that powdery mildew from getting to the lower leaves of the plant. Because once it gets to those lower leaves of the plant, that one spore I showed you can, within a matter of days, produce hundreds of thousands of spores, and there's nothing you can do. And this is what I mean by flattening the curve. You want to stop that one spore early on. And obviously, if you could stop each and every spore, you wouldn't have a problem. Some of them are always going to sneak through. You just don't want 100 sneaking through, because that 100, if each of them produce 1,000 spores, you're suddenly looking at, 1,000,000, and the numbers easily, literally mushroom, pardon the pun, from there. So unlike a lot of what I've talked to you before that wasn't effective, we have products that are really effective for powdery mildew that are also organic or 25B as well. And this would be the bicarbonates, and this is potassium bicarbonate, or your soaps. And this could be calagreen or millstop. You want to spray when the temperature is above 50 degrees but below 90 degrees. And the reason for this is if it's above 90 degrees, you'll deep fry your plant. I mean, this is soap and oil, and you'll do terrible things. If it gets too cold, it also tends to be phytotoxic as well. And so you want to be really careful with that. And when you're covering your plant, it's really important that, when you're spraying these products, that you get underneath the plant, because powdery mildew will infect on the underside of the leaf and then work its way up the plant. And you want to make sure you start low. Most of the time people come over the top and they miss that under part. And that's why the disease takes off the way it does. Sulfur is an interesting conundrum for those of you who are organic producers. Sulfur is a very good fungicide when it's dusted on top. Sulfur being burned is actually not labeled anywhere. And this is like one of those things that people kind of freak out when I mention that, but it's something that we've done for over 100 years, actually probably going back to Roman times. It's been well documented. The problem is one, it's not labeled, and you forget about getting in trouble. It could be really damaging. And I've witnessed this firsthand with a colleague who is asthmatic and walked into a greenhouse where they had burned sulfur and it almost killed him. So, keep in mind some of the dangers that, as we're trying to be more sustainable and safer, that we don't make a mistake in that process. Using sulfur dust, though, can actually be an effective way of managing powdery mildew. Keep in mind that you can cause mite flare-ups, but that you have to go talk to Suzanne about. All right, now I'm going to shift over to the leaf spots, and we have a rogues gallery of leaf spots here. Very proud that all of these are photos that we've taken out at our site. And so I'm going to start with the big one, Septoria. This is a huge problem in field production. I've not had any people telling me they've had problems in greenhouses, but I have seen problems in hoop houses. And you end up with these yellow spots. They tend to get much worse. If you look closely at them, you'll see these little pustules. And sometimes you might see these pustules producing these threads. And these are the spores. And this is when we talk about flattening the curve. And, I showed you how that one powdery mildew spore can easily grow. Septoria does the exact same thing. And, one spore will produce this lesion here. And this one lesion here, you could easily see, I'm going to say 60, maybe more pustules. Inside each one of those pustules is about 10,000 spores. So we have 60 by 10,000, which brings us to 600,000. And that's just one leaf spot. Look at all of the leaf spots we have here. So you really, really want to make sure you don't get those spots established. And I'm going to just go over a bunch of different foliar diseases. Again, you need a microscope. Here's extrohilum. Hopefully you can see the difference between the spots. Not quite the same halo, a darker brown spot. If you look with a hand lens, you can't see a pustule. These guys are just coming off on like a simple branch, but they do produce these big spores over here, but they're not really as big compared to this leaf spot here, which is called Dreschlera gigantea. Here we used a banana for scale, and I'm only slightly joking. These spores are so big you can actually see them with a hand lens. Hopefully just by looking at these lesions, you can tell some of the differences. But again, to be absolutely certain, you would need a laboratory diagnosis. That said, I don't know how much it matters because we aren't working with conventional fungicides for their control. Phoma, if I had to tell you a favorite leaf spot, this is my favorite leaf spot. We got absolutely wrecked by Phoma the last 2 years. It started off as a minor problem that produced these kind of zonate crusts. Here it's just so photogenic, and here you could see the cirri, or the oozing tendrils of spores that this guy produces. This will affect the leaves. It will also affect the stems, causing the plants to lodge or fall over. It causes a canker, like what you can see right here. It also causes a bud rot as well. So we had FOMA out the yin yang and probably had at least a 20% loss. In the greenhouse, you will not have most of these problems. Like I said, we have seen a little bit in hoop houses and large warehouse operations. The biggest and most important part of this is making sure that you're spacing and keeping your airflow. As long as leaves are drying, you aren't going to have this problem. If you are irrigating with spaghetti, that is no overhead watering, but using lines, that will keep the foliage dry. All of these pathogens need free water on the leaves in order to infect. So that's the good news. If you aren't overhead watering, you can reduce your risk of any of these foliar diseases. The bad news is you might end up with powdery mildew, unfortunately, but we can manage that. So that's a good trade-off in my experience. Once again, I'm sorry for anyone who might have a fondness of the cherry lines. That seems to be the one that we had the worst problems with, powdery mildew and Septoria. Downy mildew. This is another one. In the last 2 years, we've had some serious issues. The first problems we were hearing tended to occur up in Wisconsin. We believe that the problems that we have did not come from the agronomic hemp, but actually came from the CBD hemp. There's a very good chance it comes in on seed or it comes in on cuttings. So for over 5 years, we grew acres of hemp without any problem. And the second we put our operation outside with a number of different cultivars is when it actually blew up. And so it probably came in on one of those. What I want to show you here are some of the symptoms where the plant, literally this was in a 3 to 4 days, they all went from looking normal to the foliage started to look yellow, then it started to curl and fall off. If you look at the upper leaf surface here, it has these angular yellow lesions. If you flip it over, this is chock full of tens of thousands of spores. And these spores are able to persist. And so we'll be looking at this again next year, I'm afraid, or this year coming up. Starting with disease-free material, unfortunately, I don't know of any companies that have a screening program or also disease-free seed. We're currently testing, trying to see what's going on if ours came in on seed. To date, the test has been negative, but we're still trying to, that could be a false negative because we don't have the test worked out. Some of what needs to be done to manage this, once again, watering early in the day and taking it easy on the fertilizer. In other plants that I've worked with in ornamental production, making sure that the plants were under fertilized. Once again, this is where growing organically is a huge benefit. I'm not saying it's going to keep you from getting the disease, but it will make the delay in the disease progression slower. And so you might be able to harvest before you end up having symptoms and lose your crop. It's important to keep in mind that downy mildew can overwinter. And so once you get it into an operation, it's going to be really hard to get rid of. If you aren't completely organic and using the phosphorus acid fungicide, which is a biorational, low impact fungicide, at some point there have been some OMRI, but they tend to go up and lose labels. And I don't want to misrepresent it. I don't know of any that are labeled right now, but that is a possibility maybe down the road. You can use the BA fungicides, the Bacillus amyloquofaciens. I don't think you'll get very good control. The biggest things would be making sure you water early in the day and try and keep plants dry. All right, this last group of disease problems are unfortunately the unknowns. And if somebody would have told me, oh, at any point in my life, I'd be quoting Donald Rumsfeld and not making fun of him, I would have died of shock. But he did bring up the unknowable unknowns. And this is like what you don't even know you don't know. And unfortunately with cannabis, there happens to be a pretty big subset of this. Most of this, sorry about that, is actually viral problems, but we do come up with things that we weren't expecting or weren't aware were going to be problems in this country. That would include downy mildew. I didn't discuss rust, but that one was a bit of a shocker as well. And of course, we have issues of chimera. So make sure that you're dealing with a real disease problem versus an abiotic disorder. What to do when we're managing viruses. This doesn't matter if you're organic, conventional, we're all going to do the same stuff here. And this is culling the plant and destroying it. Trying to get it diagnosed, because if you're having this problem, odds are other people are too, and it's a way to get the word out, particularly if cuttings are coming from one specific grower. Generally, what we're seeing is that there are viruses coming in on cuttings, would be the primary way, but viruses also are going to come in on be vectored by insects, and some of these insects include aphids, thrips, and whiteflies. And so making sure that your insect vector is properly managed. Last but not least, this also includes the human vector. Tobacco mosaic virus is known to be spread by humans who are smokers. And so making sure that if you do have smokers, that they are wearing gloves at all times so they don't accidentally infect the plants, because that's a thing. So I hope some of this cleared things up for you. I need to acknowledge all the people that we have worked with from the beginning. I want to just bring up, there's been so many bad issues with the police, which I have no doubt happened, but we've been very fortunate in working with the Indiana State Police, who have been absolutely fantastic in so many ways. And I wish I could tell you some of the stories. But they have been incredibly helpful and supportive in this process. My undergrads who did the Pythium work, colleagues, including Leah Sandler, who's out west still working on cannabis, last I heard, and of course the funding agencies that have supported us. I am happy to take any questions. I hope you have them.
Thank you.
I'm going to jump in front of everybody else in case anybody else has questions, because I have a question regarding the tobacco mosaic virus. Oh, can you hear us? Yes. Okay, great.
Yes, I can.
So this has been kind of a contention point in the industry for a really long time. We know there's a bunch of different mosaic viruses that can also infect cannabis and hemp, or cannabis is hemp really, but the big thing is people who claim that they have TMV, nobody's been able to show actual diagnostic evidence from a lab that shows it. Have you guys actually seen like legit TMV in cannabis?
Actually, no, I have not.
Okay.
So, but that said, I can honestly say, I mean, I've been doing this for 35 years and I've only had 5 or 6 instances of seeing TMV anyway, but I do want to caution people that one of those instances was a greenhouse production operation where somehow they didn't know or didn't miss it, and their greenhouse manager pretty much infected every plant in the greenhouse.
Oh.
So I can't even, and so I can provide you with pictures of dozens of different plant species that get it. I have no doubt that cannabis in all of its form gets it. How symptomatic it might be is questionable.
Mm-hmm.
I just haven't spent the time to sit there and do so. I mean, it's proving that cannabis gets TMV would be like me trying to prove water is wet. I can do it, but it still is a lot of time and effort.
Yeah.
So that's probably why it hasn't been done.
It's just an interesting one because a lot of people that are smokers are like, well, you can't prove it. I'm like, well, you can't really disprove it. I mean,
we could prove it, but I don't really care to spend several thousand of my hard-earned dollars proving something I know is a fact when there are so many things that we need to figure out.
Yeah.
So, I mean, and that's the issue there. And I suspect most of the other pathologists would agree with me. Now, if I end up with like, I need to come up with an undergraduate project for somebody, and have them do it at some point. We can, a quick project for somebody to do for their senior thesis, that might be something at some point maybe I can gear up to do. I'm not trying, I mean, I totally understand what you're saying. We live in a world where some people think COVID is a hoax. I know people who died from it, so I don't know what to say when people say you can't prove it. It's the world we live in.
And then a question was asked that for clarification that there are other mosaic viruses that also infect cannabis. Can we tell them apart visually?
We can't tell, nobody can tell a virus apart visually. So you can get cucumber mosaic, Arabis, alfalfa. There's lots of different, unless you take it to the lab and spend the money, you can't distinguish those, unfortunately. I can't distinguish those either. Nobody can tell you that they can. There is actually some work. I saw somebody had a dog back there. They're actually working with dogs to do that. And in other crops, because the dogs are just so incredible in their ability to detect, and that might be a long-term solution. But in the short term, it goes very similar to that slide I showed you, that you have to grind up the plant, extract the virus particles. You have to do another step where you do a reverse transcriptase to take, because most plant viruses are RNA viruses, similar to HIV. So you can get the DNA complement of it, and then you can sequence the DNA to find out which virus it is. Or you can use an ELISA test, which is an immunosorbent assay, which uses antibodies to detect, but you can't do that for all viruses.
Awesome.
So if there's common viruses, though, that you see, like in the greenhouse industry, we had huge problems with impatiens necrotic spot virus and tomato spotted wilt. They have these strips similar to, a pregnancy test or a COVID test, and you can buy those, and a package is $35 to $50, and it's a couple, I think it's about 20 strips that you can do the test yourself. So those are available through Agdia.
Was there somebody that, yeah.
I was wondering if you've heard of using hypochlorous acid in a dry fog to prevent powdery mildew or actually kill it. I've read up on it, and they say you can do it in 30 seconds. It kills the spores.
Can you repeat the question? I can sort of hear, but
Yeah, so the question, I got it. So the question, oh yeah, if you want to come forward, but otherwise, so the question is if you can use hypochlorous acid to kill the spores of powdery mildew.
powdery mildew is a very weak pathogen, so it's very easy to kill. So you could use a lot of things. The trade-off is you want to just kill the spores of the fungus and not damage the plant. And so hypochlorous acid probably wouldn't be.
There's clarification in a dry fog.
Ooh.
They use it in hospitals.
Yeah, so when we talk about fogging, and we do a lot of this in the greenhouse, most labels don't recommend, nobody's done the test. Okay, so that's the issue is most, I have no data. I'm sorry. Will it work? Probably. My concern would be, does it damage the plant? And two, what kind of residue is left on the plant?
Thank you.
Sure. I'm sorry, I don't have a better answer for you. When even like for conventional products or other, once you go into fogging, all of the companies, whether you're organic or conventional, they all just kind of take like 3 steps back and they're like, we don't know.
Hey, so thank you. This has all been awesome. I was interested if you could help me with sizes on these pathogenic fungi. So the soil ones, the Pythium and the Fusarium, and then all the spot options and the Downy mildew. So when looking at the hyphal content, are we less than 4 micrometers wide?
It depends on which fungus. Some of them are actually pretty large. Most are probably, so that Dressler gigantea is over 100 microns. That's why it's called gigantea, because it's huge. Pythium, we're looking, the hyphae are a few microns across. How long they are depends on, how well it's growing and things like that. But
I always look at width when identifying kind of an SOPs for aerated compost teas and things.
you can't identify fungi based on their width. You have to get them to sporulate and look at their fruiting structure. So you have to look at the spores.
Cool. What is everything round-headed, sporulating body, and is there a particular spore?
Oh no, there's literally like there's dozens of books for different groups of fungi. I have literally this is terribly nerdy, but I have 2 bookshelves full of books to help me identify different fungi. I would say the best way of trying to, it's
Awesome.
really
It's amazing.
so,
Yeah.
well, but it's you can say that, but I taught this diagnostics class over the summer with the 5 students, and I think at any given point in time, everyone is in tears because it's so frustrating. Well, and it is frustrating. So what I would recommend, if you want some specific books, if you shoot me an email, I can give you a list of some specific books to help you with that.
Absolutely. Can I also make the question broader and see if maybe
Sure.
they're comfortable answer?
Jana, if you want to email that list to James at Organic Cultivators, we'll go ahead and put it on the website and on our Facebook group. And that way everybody has access and you don't have to answer it a million times.
Okay, I'm just writing it down so I don't forget after this, because I have no short-term memory anymore.
We'll remind you.
Okay, good.
If you're looking at a slide and let's just say it's just like a soil sample, is there a way you would be able to tell a mycorrhizal or saprophytic fungi apart from a pathogenic or like airborne leaf?
No. Well, so there's a couple of issues there when you're looking at a soil sample. Because there's the soil, it's very hard to see anything. And so a lot of times we'll try and bait things out of the soil in order to see what's there. And then the other issue is, just because you find a spore in a soil, it doesn't mean that it's viable. And so that's a huge problem. It doesn't mean that, and this is one of the issues we have with, like, when we do these DNA tests, we can PCR the DNA out of anything, but that doesn't mean that it's alive and able to cause disease. So that's why we do all of these different tests. So the short answer is we can't look at the soil. We have to generally try and bait things out. And in this process, now we can bait out certain mycorrhiza, we can bait out certain beneficial soil fungi, we can bait out bad soil fungi, same with nematodes and bacteria. But it depends on having the media to select what it is we want.
Cool, thank you.
Sure.
One more question. Hot latent viroid, can you speak about it?
Yeah, boy, that's been a huge problem. And we've been seeing it for the last year plus. It's absolutely a problem. Unfortunately, people aren't paying to get the diagnosis. So we don't know the extent of the problem. And we don't know if a lot of the people claiming that it is a problem, if it really is the problem. So if you think you have it, please send some samples in. You can also contact me. I might be able to come up with some money to do this test for you, so you don't have to assume the cost for everyone's benefit. We do have some evidence that it's coming in on certain cuttings. And this is one of the problems with viruses. They can be asymptomatic for a very long time before the symptoms develop. And so certain growers have mother plants that they're propagating. And then once the plants are all out there, and this isn't just for cannabis, this is everybody, the virus shows up. So.
And just for everybody who's listening and those who are watching later on, those tests are not extremely expensive. In California, it's $120 for a setup and then $22 to test every plant thereafter. You can do, like, it's our lab that we work with is ALL Crop Solutions in Visalia, I think, or something. It's in Central California. And it requires like some leaves, so you don't even have to send in the whole plant. You can send in about 5 to 10 fan leaves. It's incredibly important. Our farm has suffered from it at least once, possibly twice, and it can be devastating. It can ruin your entire year. So this is a really important one to start being diligent about.
Don't really know you have it.
And you don't know you have it until bloom. You're well into blooming when things start going a little bit wonky for the most part. We also had it at the beginning in cuttings and had weird things happening. So
And that's sort of the tip off, when things are a little wonky going on and making sure you're on top of it early on. The next thing is to make sure that you're going to a reliable lab. I can't stress that enough. I don't know about the lab that you just mentioned. I'm assuming they're good, but I do know, having gotten emails from a number of different people, there are a lot of scammers out there.
Yeah.
And so to be careful.
What a,
I think she just said she doesn't. Do you have a list of good labs, Janna, that you know of, or is it just more of
So,
like
I would say, starting the Purdue Plant and Pest Diagnostic Lab, we charge $11 for people in the state of Indiana, and we charge $22 for people out of the state of Indiana. You aren't going to find anybody anywhere cheaper. To do a virus test, though, there are other costs that we will have to pass on to you. And all I can say is that the two, I don't do this work. These are my colleagues, John and Tom. And I just think they're phenomenal. But there's other labs. Agdia is one of the labs that actually produces a lot of these tests. So they would be a reliable place to go for. None of these people are making tons of money. And I would say go to people who aren't necessarily actively courting the cannabis community, because suddenly there were a lot of people who came out of nowhere courting the cannabis community, and they aren't necessarily, I'm not saying they're necessarily bad, but they don't have the history. They saw an opportunity to make money versus somebody who, our lab's been doing this for over 100 years. So
in relation to other pathogens you've worked with, what do you think the likelihood that if you had two plants with hop latent viroid and they made seed, that the offspring would or would not have hop latent viroid?
I don't know of any data that shows that virus is seed transmissible. Very few viruses actually are, but there are some. So I don't want to say that there's no chance. It depends on the virus. And I will be the first one to admit, since this is Sunday and I'm not like really on the clock here, can I just swear?
Yep.
Okay. I'm a shit virologist. My attitude when I see like a virus problem is throw it away, find out what it is, throw it away. Find out what it is so you could figure out how you can control the vector, throw it away because there's nothing else you can do with it.
Thank you.
So that's, sorry, but I'm a shit virologist.
The real answer is the good answer. Thank you.
Yeah.
Okay.
So I just wanted to touch back on HLPV. Do you think there's any validity to the companies that are selling home tests for HLPV?
So,
and I think I sent you a link.
Yeah, you did. And I was just, and I sent that to my colleague, Tom, and we were both a little taken aback. So I don't know in that instance. I can see where it could be possible, because what they're saying they're doing is essentially it's like sending you a pregnancy test to do at home or a COVID test to do at home. So is it possible? Yes. I don't know the accuracy of that test. If they were sending you like, we have at the PPDL, and like when I teach my class, I have tons of, little containers that have, to test for cucumber mosaic virus, alfalfa, Arabis mosaic virus. I think I have about 20 different tests that are just like what they're sending you. So there are tests out there that are legit. That's assuming that the test is still good. Was it stored properly? So even if the test was good, if it was improperly stored, you could end up getting a false positive or a false negative. And so the answer is, I really am not sure. I'm kind of a little suspicious. I might follow up with you on that and maybe order some and do some tests. Just to see. Yeah, do some double blind. I hate doing that though, because it's like, everybody's, it's a balance between trying to support people and help them make a living versus supporting and helping people not get swindled. And I just wanted people to know I'm like right there, I'm trying to do the right thing. So
we appreciate it.
Well, I just don't know what the answer is anymore.
Neither do we, trust me.
All right, guys, we got time for one more question before we wrap up. We got another question.
I think our minds are jelly at this point.
Well, then my work here is done. Thank you.
Okay, thank you, Janna.
Thank you,
I will be
Janna.
in
Thank
touch.
you. I'll leave here. Take care, everyone.
Bye.